So, hello everybody, it's 3 p.m. Let's start with our webinar. A warm welcome to everybody to the webinar Innovative Hinge Solutions for Advanced Smart Glasses. It is our third webinar about hinge technologies in this new exciting segment of eyewear, and we are pleased that we have more than 50 registrations from many countries to this event. As in our previous webinars, all participants are muted, but of course you can give a comment or question in the chat area. At the end of the presentation, we will answer to the questions if they are not too customer specific. But let me first introduce myself. My name is Frank. I'm in charge of the marketing at the OBE group.
And I'm the other Frank, in charge of the development at OBE, precisely hinges for smart glasses.
Let's start. In this webinar, we will explore the mechanical solutions that power the innovation behind smart glasses and discuss how they enable the integration of technology into the eyewear. Here we can see a complex hinge representing the very first smart hinge which OBE developed in 2012. Later, my colleague Frank will provide more details about that. Here's some information about the company, but I think the slide is not working right now. Okay, I was too quick. So our company was founded in 1904, and we specialized in the optical industry starting in the 1970s. We have been highly innovative and having 200 patents worldwide, and each year we produce about 500 million parts. We have production sites in Germany, where our headquarters is located, as well as in China. This year we acquired a majority stake in an Italian company specialized in luxury frames. By 2025, we will begin operating a new facility in Vietnam. Each year, we equip about 100 million frames with our products and hinges. Since 1996, we have been certified under ISO 9001 and the environmental standard ISO 1401. Additionally, since 2013, we have been active in the smart glass market, offering advanced high-quality solutions. Here you can see a selection of our reference customers from the eyewear market. For all customers, we offer an extensive catalog featuring a wide range of standard solutions. In addition to our standard offerings, we also provide customized solutions tailored to the specific needs.
Like this one, as Frank already mentioned, this is our very first excursus in the smart glasses segment. This hinge was constructed under a joint venture between the optical giant Luxottica and Google. The aim was to switch the temple from a standard regular glasses temple to an electronic loaded smart temple. So you easily could switch between having the additional functions or not having it. This already showed that the smart glasses tend to come more and more to look like standard glasses. Sorry. OBE's quality is guaranteed by several tests, like cycling test, inclination test, pull-out force testing, and all of these tests, of course, have to be transferred to the smart segment as well. As you can see here, the standard spring hinge movement with 2 stable positions for wearing and storing, as well as the overextension, need to be guaranteed by the QC. If it comes to not having a flex function, but regular hinges, we also have a movement control by the use of plastic-coated screws, like these patented space screws, having an overmolding over the screw shaft by plastic, and in addition, 6 small ribs to compensate the tolerances between the hinge lug and the screw shaft.
From niche gadgets to everyday essentials, Frank highlighted our basic criteria for hinges, noting our reputation for spring hinges and precise movement control enabled by our space screws. Building on these fundamentals, I'd like to explore the key factors of smart hinges as they are becoming increasingly more daily, common in our daily lives. Comfort. The hinges in smart glasses play a crucial role in ensuring overall comfort. They must be flexible enough to minimize the pressure on the wearer's head while simultaneously providing a secure, stable fit. Of course, the weight of the hinge also affects the comfort. Lighter hinges can help reduce the overall weight of the frame. Durability. The second key factor for smart hinges is durability. It is essential that the construction of the hinges matches to the frame in order to ensure a long lifespan. In cases of breakages, an exchangeable system helps to replace only the mechanical part by saving the total frame. We believe also that adjustability of the temples to fit the specific wearer will become increasingly important in the smart market. To enable this adjustment, the hinge must be stable to prevent the breakage. Additionally, the frame and hinges should be designed for an effortless use without being overly rigid. Foldability with cable. In the case of smart hinges with a cable feed-through system to the front, foldability is one of the key factors for creating a successful portable smart frame. Foldability implicates that the cable is routed friendly in a channel without being stressed. In addition, an easy dismounting of the cable through the hinge is helpful to repair the electronics in case of malfunction. Connection. An interesting aspect of smart hinges is the connection between the hinge and the temple. In our experience with various projects, we found that the smart eyewear market is usually connecting with mechanical methods, such as screws, rivets, or plug-in methods. In contrast, traditional eyewear often uses soldering or welding, which in the smart market can potentially interfere with electronic components. Finally, let's turn to our smart solutions, which we differentiate into 2 categories. The first category mainly involves solutions for the temple, where the electronic device is located on the temple and does not transfer information to the front. For this type of smart eyewear, we offer several solutions. For the second category includes hinges or solutions for smart glasses with a cable feed-through system, where signals, information, or data are transferred from the temple to the front and to the other temple. In this case, the hinge requirements are different, and we also provide tailor-made solutions for these needs. Let's come to the first category, pure temple solutions. This picture illustrates, in fact, the first category of pure temple solutions with no signals to the front. Among our portfolio, we have selected 3 different hinges with a mechanical connection and non-flexible functioning. These hinges are equipped with a smooth movement system, a space screw system, and are connected using screws and rivets. All of them made by high quality materials, and they are nickel plated and come fully assembled as shown. Here you can see one of these hinges applied to the frame. This hinge, called gappy, creates a distinct gap between the temple and the front of the frame. The metal part located at the border serves as an orientation for the wearer, indicating where the temple begins, as in that area the smart function is activated by the fingers. In the pure temple flex solutions, the second category, you can see two products here, both used in the smart market. What they have in common is that they are equipped with a stainless steel mechanism featuring a 5-barrel concept. You see this in the heart, making them very stable. The difference between the inflex on the left side and the plug-and flex is that the inflex is connected by screws, whereas the plug-and flex is inserted and fixed directly into the temple. Additionally, the plug-and flex does not have any front hinge, whereas the inflex is a fully integrated version with both temple and front hinge. Here you can see an example of the inflex product, which has been customized to meet the customer-specific needs. It was especially coated, and the connection technique for the screw was changed from the bottom to the top. No, from the top to the bottom. Additionally, the opening angle was limited according to the customer's request, and a special spring was used to achieve the desired soft flexibility.
But if it comes to data being transferred from the front to the temple, or vice versa, the FPC or the cable has to run through the complete front and especially through the hinge area. This might end up in a problem that the FPC is stressed by several bending operations, which leads to a challenging new topic. To dimension the cable and the cable weigh perfectly. Either the cable is too long in the open position, so it will be pinched between front and temple, or the cable might be too short, which leads up in a stress or even in a tear when the temple is closed. For this new task, we provide two different products, one with non-flex operation and one with spring loading, the Smart Link and the Smart Flex. Starting with the Smart Link, the cable is allocated in its track thanks to the slit in the hinge. And the curved construction of this slit prevents the cable from any tangle. Instead of bending, as usual, the cable and the hinge 90 degrees at once, thanks to these twice 45-degree bending solutions, the cable is not stressed when the temple is folded. The cable is perfectly guided and protected from any accidental contact. So the SmartLink provides an integrated slit suitable for cables up to 4.4 millimeter in width, or FPCs, of course, with the cable-friendly shape. The material is stainless steel, radical stainless steel, and it's constructed for universal use. And of course, we have a patent on this construction. Another important feature is that due to the open design slit, the FPC or the cable can be easily assembled and disassembled in case of electronic malfunction. In combination with the OBE space screws, the SmartLink provides a perfect comfort with a smooth movement. And in addition, with the two spring-loaded pushers, you have a stable opening and storing position. So the SmartLink is a perfect universal solution with a cable guidance for less cable stress. It's constructed for easy handling, and it guarantees a smooth movement. Like one of our bigger customers, Morrow Eyewear, is using this product. You can see on the pictures, the FPC, the cable or the data shown in green, is led through the complete front and through the SmartLink, ending up in the temple where the electronic is located. If your frame is more rigid, or you want to provide extra comfort, you might consider using the Smart Flex, adding an overbending function compared to the SmartLink, as you can see here. The Smart Flex consists of more components than the SmartLink, of course. We have a housing in the front hinge and two spring-loaded pistons providing stable closing wearing positions plus the overextension function. Due to this additional spring function, the product, of course, has to be bigger than the SmartLink. Considering the same FPC size of 4.4 millimeters in width, we end up at a total width of 10.4 millimeters. The weight of the complete construction depends on the material used. The standard optical material is nickel silver, which of course is very heavy. So you might as well consider titanium, which is more expensive, or aluminum as a pretty exotic and new material in the optical segment, but saving up to 50% in weight compared to titanium. As a SmartLink, the Smart Flex also is equipped with an easy assembly construction for the cable. You easily can insert it into the open cable channel. And the magic behind this solution is to position the cable right inside the neutral fiber, so it won't get any stress by bending. Compared to the outer position marked in red, you can see the elongation of the cable by this red curve. We save this by having the cable led through the neutral fiber. These pictures show the stable wearing position, the also stable storing position, and the spring-loaded overbending. To provide as much variability as possible, you can choose the fixing positions of the screws, of the 4 screws, having it on the inside of the frame, laterally or vertically. If you have special needs for more data to be transferred between temple and front, we even can create a larger version of the Smart Flex. As you can see on the left side, the standard has a 4.4 millimeter FPC channel, ending up at 10.4 millimeters total width. You might also decide to use a 10 millimeter FPC, which ends up at 16 millimeter total width. Or you could go the other way and having as slim as possible temple. We even can skip one of these spring functions and replacing it by a regular hinge to save more in width. Due to the just mentioned construction, we create a small gap between front and temple, which is necessary for the overbending function. But this can easily be covered by the outer shell of your smart frame construction.
On this slide, we present the two cable feed-through solutions from OBE. The Smart Link on the left side is smaller and focuses more on the smooth articulation, while the Smart Flex on the right side offers, as Frank mentioned and explained, overbending capabilities, making it larger due to its added features. SmartLink is already available in a serial production, whereas the Smart Flex is still under development and will be available in 2025, so next year. A detailed timeline will be shared soon. So finally, as a summary, we'd like to provide some helpful tips for developing smart glasses and considering the articulation of the hinge. First of all, as it was explained in the last slides of the Smart Flex, if a cable is integrated, it is important to account the width and the thickness of this inner component, as well as its application within the hinge. So consider the FPC or the cable. Secondly, a key question is whether the frame is rigid or flexible, as this determines the choice between flex or non-flex hinge. Keep in mind that the hinge is available in different materials, each with distinct properties that influence the weight. Additionally, the size of the hinge must be compatible with the frame's construction. Corrosion might be an issue if the hinge comes into contact with aggressive substances. In this case, we offer coatings or non-corrosive materials like stainless steel. Allergies, on the other hand, are occasionally relevant, but are mainly, I would say, psychological concern, as the hinge itself does not come into direct contact with the wearer's skin. Other aspects to consider include the method of adjusting the hinge to the wearer. Different hinges have wearing properties that influence the adjustability. Heat resistance or conductivity of the hinge could also be relevant in relation to the electronic device, making the hinge an important factor to consider. In all these aspects, OBE will guide you in finding the best option for the specific application. So more or less, we have finished our presentation, and we have just have a look if there are in the chat some questions, which I just have to check, and I don't see any questions. So if there are questions which are much more related for the customer needs, we can answer them later on individually. And therefore, would like to thank you all for attending our webinar. We'll send the presentation together with a small survey about this event after the webinar. And if you have specific questions, don't hesitate to contact us. We will be happy to help you and develop with you the next generation of smart glasses. Thank you for your attention and see you next time. Bye-bye.
Bye-bye.